In this video, we'll explore how a gym manager can use logistic regression to better understand and predict member loyalty. The manager is concerned about the attrition rate at her gym. She would like to identify the profile of loyal members who retain the membership for at least 1 year. The company data file contains information on whether the member has been loyal. In column A, a 1 indicates the member has stayed at the gym for at least 1 year, a 0 for otherwise. Also included are the member's age, income in thousands, and whether the member joined on a single or a family plan. Logistic regression is our tool of choice. It's great for situations where the outcome is binary, yes or no, or in this case, loyal or not loyal. It looks at the relationship between our predictor variables, in this case, age, income, and what type of plan they're on, and the probability of them being loyal. The result is a model that can give us an estimate of the likelihood a member will be loyal. Let's run the analysis. Click on Data Science, and under Classify, we're going to select Logistic Regression. Make sure the appropriate data range is selected, A1 to D201, and that the first row contains headers, since that's where our labels are located. Our output variable is loyal, so I'm going to select that and put it in the output variable. That's what we're trying to predict. 0 indicates a customer will not be loyal, 1 indicates they will be loyal. And the variables we're using to predict this are age and income. I'll put those in selected variables, and the categorical variable plan. Plan is a categorical variable because it indicates which type of plan they have. It's not a numerical variable like age and income. So select plan and put that into the categorical variables box. Leave the other defaults as is and click Next. We'll select Variance Covariance Matrix, then click on Next. Under the Scoring tab, make sure Summary Report is checked, and then click on Finish. Several new tabs appear now with the logistic regression output. Let's start with the first one. Let's start by looking at the coefficients. This will really tell us what the relationship is between our independent variables, age, income, and what type of plan, and how they affect whether a customer is loyal or not. Because we have a positive coefficient for age, that indicates the older the member, the slightly higher the probability of loyalty. Same with income. Higher income is associated with a higher chance of loyalty. The plan type indicates that members on individual plans are less likely to be loyal than those on family plans. Notice that if a member is on a family plan, this positive coefficient relates to a higher probability of loyalty, whereas if you're on a single plan, there's no positive contribution. Let's use our model to make some predictions. Let's assume that a member is 40 years old, makes income of $80,000, and is on a single plan. So I'll put a 0 for the family plan. And we'll make a prediction about another member who instead is 60 years old, again makes $80,000, and is on the single plan. So I'll put a 0 for the family plan. The logistic regression equation is modeled by this formula. The probability of success is equal to e raised to the intercept coefficient plus the x1 coefficient times x1 plus the x2 coefficient times x2 and so forth, divided by 1 plus e raised to the intercept coefficient plus the x1 coefficient times x1 and so forth. This is how that equation translates to our problem. The probability of being loyal is equal to e raised to the intercept coefficient plus the age coefficient times their age plus the income coefficient times their income plus whether or not they're on a family or single plan. Let's follow this formula and compute this probability in Excel. So equals exp returns e raised to the power of, I'm going to first reference the intercept plus the age coefficient times the member's age, in this case is 40, plus the income coefficient times the member's income, plus the family plan coefficient times yes or no if they're on the family plan or not. That's the numerator. I'll divide this by 1 plus e raised to all of that again. Just to save some time, I'm going to copy my numerator and paste it in for the denominator. Here's my computed probability. I'm going to format it, convert it to a percent, and reduce some of the decimals. Edit. So there's about a 30% chance a 40-year-old member making $80,000 on a single plan will be a loyal member to the gym. Let's do the same thing for member 2. To make this easier, I'm going to lock in place all of my coefficient cell references, which are all of the D ones, so I can simply drag it across. To do that, I'm going to use the F4 key, and it puts those dollar signs around those cells, locking them into place. Now, when I drag my formula across, the coefficient cells are locked into place, and now I'm referencing the attributes of member 2. And the probability of a 60-year-old member making $80,000 on a single plan jumps up to about 48% of being loyal. Again, we noted that the older the member is, the higher the likelihood they are of being loyal. Now that these formulas are into place, we can change whatever variables and recompute the probability quite easily. Let's say that member 1 now switches to a family plan. I'll put a 1 here. The probability of that member being loyal jumps up to 51%. We can do a similar thing for member 2. That probability jumps up to 68.8%. Under the Logistic Regression Training Score tab, we can also see the different performance metrics, just like any other model we would.